Hello everyone, this is Jared Cadman, Associate Professor of Engineering Technology at Lone Star College again. And right now I'm going to talk about how to calculate the coefficient of friction using the angle of repose. And so the question is, what is the angle of repose, first of all? Well, the angle of repose is the angle at which you can have an object to overcome the force of friction and start sliding down. Okay? Now, when we have an object and we put it on an inclined plane and we can create an angle so that it just starts sliding down, that's the angle of repose, and we can use that information to determine what our coefficient of friction is between the two surfaces, in this case between the inclined plane and between this block here. Okay, so we're going to assume here that we have a weight, and we're just going to call that weight mg. Okay. So we have a weight here, mg, so that's a mass. Let me write that a little bit bigger. Times the acceleration of gravity. All right. Now, from this point, what we're going to do is we're going to draw our free body diagram. Okay. And in drawing our free body diagram, we're going to go ahead and rotate our axes counterclockwise the amount of whatever this angle is. We just don't know what it is yet. Okay, so when we rotate and draw our box again, I'm going to draw it big so you can see it. We have several things going on here. All right, here's our surface, or here's our plane. It's been rotated counterclockwise by 30 degrees. That means that what used to go straight down, as in the weight, is now going at an angle, and that angle is going to be 30 degrees. All right, so here we have the weight coming off at theta, not 30 degrees. We don't know what theta is yet because that's the angle of repose. I'm sorry. Our weight is going to come off at some angle theta. So here's our weight. So here's mg. Okay, that's going to be our weight. Now, in addition, we have some other forces going on. We have our normal force, which is perpendicular to the surface. So here's a surface, so normal force is going to go perpendicular to that. Okay. Then we also have our friction force, which our friction is going to oppose motion, since this way is where the motion is going. Friction force goes the other way, parallel to the surface. Okay. So that's going to be the force of friction there. All right. And so, since we have a slanted force, we're going to break this down into rectangular components. Right, one going down and then one going to the left. So that means that this component is just going to be the magnitude times the cosine, because it's the adjacent side. So this component is mg cosine of theta. Okay, and this component here is going to be the magnitude times the sine, because it's the opposite sign from the angle. So this side right here is just going to be mg times the sine of theta. Okay. And so to go ahead and analyze what's going on, we're just going to do our equilibrium equations, which is to say that the sum of the forces in the x direction is supposed to equal 0. What do we have in the x direction? Well, we have our friction force. So that's negative friction force. We're going to the right is positive, so we're going to subtract friction force that's going to the left. And then we're going to add this mg sine of theta, so that component of our weight, and that's going to equal 0. All right, and so what we can do there is we can solve and say, hey, then I know that the friction force is just going to be equal to mg times the sine of whatever that angle is. Now I do my other equilibrium equation, which is the sum of the forces in the y direction, with up being positive. That's going to be set equal to 0. What does that equal? What do we have in the y direction? Well, we have our normal force in the y direction, so that's Fn. Okay. We have this component of the weight in the y direction, but that's going down, so we're going to subtract that, mg cosine of theta. And that's supposed to equal 0. And so from this equation, we find out that our normal force just equals the weight, mg, times the cosine of that angle of repose. Okay. Now, look at these two equations. All right. We can use one more equation to find out what our angle of repose is, and that is the equation where knowing the definition of the friction force, which is the friction force equals mu times the normal force. All right. And so if you don't know the angle of repose, okay, and if you're trying to find out what your coefficient of friction is, rather, which is what we're doing, then all you have to do is divide, and you'll say, hey, mu, my coefficient of friction, equals my friction force divided by my normal force, right? Now, what does that look like? Okay, because I have things that stand for the friction force and a normal force. So if I substitute those in, what do I get? Well, for the friction force, I'm going to substitute mg sine of theta. And for the normal force, I'm going to substitute mg cosine of theta. Okay? These mg's cancel, and I just get sine of theta over cosine of theta, which is the tangent of theta. So in other words, my coefficient of friction is just going to equal the tangent of whatever my angle of repose is. Right? So here's my angle of repose. So if I were to do an experiment, okay, then I would just take an inclined plane, and I would lift my inclined plane a particular angle until the box just barely started sliding down. Okay? And when that box barely started sliding down, I would record this angle. Alright? And then if I want to get my friction, coefficient of friction, all I have to do is take the tangent of that angle. Okay? And so that is how you calculate the coefficient of friction using the angle of repose. Now, some people might ask us, well, how do I determine what that angle is? I mean, physically, do I need to get a protractor? That might be difficult. You don't have to do that. All you have to do is use trigonometry. In other words, this angle, okay, you can get from the tangent, which would be opposite over adjacent. So measure this height, measure this length, and you have the tangent of this angle equals opposite over adjacent. In other words, if you took the inverse tangent on both sides, you would get that angle of repose is just going to be equal to the inverse tangent of the height over your length. Okay? And so that is how you can calculate what that angle of repose is instead of measuring it, which might be difficult. So you might be able to use this in doing, say for instance, a calculating the coefficient of friction lab, where you actually go through yourself and put two surfaces, one surface on the inclined plane and one surface on the box, and then see where the angle of repose is, take the tangent of that, and get your coefficient of friction. All right? So that is how you calculate the coefficient of friction using the angle of repose. Thank you very much.